Splicer V-grooves should be cleaned periodically with any Fusion Splicer. Especially for mass Fusion Splicers, cleaning the V-grooves is critical and should be the most frequent maintenance activity that is performed. Start with a V-groove cleaning kit. Follow the instructions provided in the kit. Gently brush the V-grooves with the soft brush to remove freestanding debris. Next, inspect visually with suitable magnification to identify any contamination present. Now, use a lint-free cotton swab lightly moistened with the cleaning fluid provided to remove additional debris. Inspect again to assess progress. If still dirty, use the stiff bristled brush to remove more aggressive contaminants. Inspect again and repeat this scrubbing process until free of debris. Lastly, sweep a final time with the soft brush to remove any loose contamination that might have deposited during this process. Do not use the brushes in this kit for cleaning anything other than the Splicer V-grooves, so you do not contaminate your V-grooves when attempting to clean them. Excessive smudges and buildup on camera lenses can cause improper fiber viewing and lead to bad splices or error messages. First, remove the electrodes so you can access the camera lenses. Use a lint-free cotton swab moistened with 99% or greater isopropyl alcohol. Rub the camera lenses in a circular motion repeatedly. Dry excess fluid and remove any loose debris by wiping away with a dry, lint-free cotton swab. Repeat this process if contamination persists. Reinstall electrodes and conduct an arc calibration when finished. The clamp chips are responsible for capturing the fiber in the V-grooves properly. If contamination is present, the fibers will not be secured in the V-grooves, resulting in bad splices. Use a lint-free cotton swab moistened with 99% or greater isopropyl alcohol to gently rub back and forth against the clamp chips to remove debris. Remove excess alcohol by repeating this motion using a dry, lint-free cotton swab. Arc calibrations are important for maintaining optimum splice performance. Without it, splices become weak or have high loss. If you are using an auto splice mode, the arc is calibrated with every splice. However, if environmental conditions change drastically or the splicer has not been used for some time, a manual arc calibration will need to be performed. Press the Arc Calibration icon from the Ready screen or select Arc Calibration in the Maintenance menu of the splicer. Prepare and load the left and right fibers. You can only use G652 Standard Single Mode Fiber, or SMF, to perform arc calibrations with AFL Single Fiber Fusion Splicers. If any other fiber is used, the calibration will be incorrect. For mass Fusion splicers, you must calibrate with whatever fiber type, SMF or MMF for example, that is appropriate for the splice mode you are using, and that it is the same as the fiber you will be splicing. You should also calibrate with the same number of fibers you will be splicing. Execute once the fibers are loaded. A message will appear showing the status of the arc's power and position once the calibration is complete. If one of these shows not adequate, perform the arc calibration again. If not used for a long time or previously calibrated incorrectly, you may need to perform the arc calibration 3 to 4 times to receive a good message for both arc parameters. Like all things, electrodes have a life cycle and have to be exchanged approximately every 5,000 arcs. Replacing your electrodes at their end of life is crucial to maintaining low loss and strong splices. Navigate to the Maintenance menu of your splicer. Select the Replace Electrodes function. A prompt will pop up listing the next steps. Turn off your splicer and remove the electrodes. Install new electrodes and power on the splicer. Prepare and load the left and right fibers into the splicer and execute the stabilize electrode function. This will run for about 8 to 10 minutes for single fiber splicers and 15 minutes for mass fusion. Once completed, perform an arc calibration. If error messages persist, ensuring proper fiber prep and all maintenance items are in check, run a diagnostic test. This test checks the overall performance and health of your splicer with several sequential tests. Each test will automatically begin after the other. Cleaning the cleaver clamp pads and anvil should be performed regularly to ensure good cleaving performance. If any type of contamination is on any of these surfaces, cleaving performance can be degraded. If you notice problems with poor cleave quality, you should thoroughly clean the cleaver before resorting to a blade rotation. Take a lint-free cotton swab, lightly moistened with 99% or greater isopropyl alcohol, and clean each clamp pad and the anvil. Rub in a back and forth motion to ensure you clean the entire surface of each item. You should not clean all 4 pads and anvil with the same moistened cotton swab. Clean no more than 2 pads with a single end of a cotton swab. Rub with a clean, dry, lint-free cotton swab to remove excess alcohol and any remaining loose debris. If cleaning the clamp pads and anvil does not solve your problems, the cleaver blade itself could also be dirty. Use a lint-free cotton swab, moistened with 99% or greater isopropyl alcohol to clean the cleaver blade. Use an upward motion up the side of the blade to pull debris off the tip of the blade without touching the edge of the blade. Use a dry, lint-free cotton swab with the same cleaning motion to remove excess alcohol and any remaining loose debris. If cleaning the cleaver does not eliminate cleaving problems, or if the cleave count is high, it may be time to rotate the cleaver blade to the next position. You can do this manually with the cleaver or with the splicer if you have our Bluetooth-enabled equipment. If the cleaver blade has already been rotated through all 16 positions, advance the blade to position number 1 and raise the blade to the next blade height setting. Do not raise the height until you have rotated through all 16 positions at the current height setting. While you may be able to strip many ribbons without performing any special cleaning of the stripping tool, eventually there may be small coating fragments that have accumulated on and just behind the blades. This can lead to broken fibers. Use a toothbrush or any thick bristled brush to remove debris from the blade, the heating area, and the rubber gripping strip. If oil or other more adhered contamination remains after using a toothbrush, you can use a standard cotton swab moistened with isopropyl alcohol to remove the more difficult contamination. After this, wipe away any remaining debris with your brush or an air source. If you are stripping web-type ribbons, such as AFL spiderweb ribbon, or if you are ribbonizing loose tube fibers, you will need to follow this process after each strip.